Okay, my name is Kate Winters and I'm in the Physics 1251 class. This is my video solution for Lawn Kappa 5, the problem about the merry-go-round. So in the prompt it says the child sits on a fiberglass swan fastened 8.6 meters from the center of a merry-go-round platform. So the first thing I'm going to do is draw that situation. This is the merry-go-round, we're going to call that the center, and the child is sitting on a swan 8.6 meters from the center. We're going to call that distance the radius 1. Then it says that this platform rotates once every 15 seconds. If something rotates once every blank time period, that's called the period, and I'm going to go ahead and write that known out right now. And then later in the problem, we're told information regarding when the child is sitting 6.7 meters from the center. So I'm going to go ahead and draw that in as well. 6.7 meters, we're going to call that radius 2. So now we have all the information from the problem and we can start working stuff out. So the first thing that we need to solve for is the speed of the child while they're sitting on the swan. So when objects are moving with uniform circular motion, you can describe the velocity as the angular speed times the radius. And you can describe the angular speed as 2 pi over t. And all of these formulas are coming from basic kinematic definitions and our formula sheet. So using these two definitions, I can say that the velocity is equal to 2 pi over t times the radius. And because we're talking about the first case scenario, I'm going to go ahead and add in radius 1. So at this point in the problem, we can go ahead and plug in the values that we already know and solve for the velocity. So the velocity, and I'm going to call this v1 since this is the first case scenario, is equal to 2 pi, those are just constants, over t is equal to 15, and r1 is equal to 8.6. And when we plug those numbers into the calculator and round for sig figs, we get 3.60 meters per second as the child's speed in the first location. After that, we're asked to solve for the acceleration of the child while they're sitting on the swan. So the acceleration of an object with uniform circular motion, so centripetal acceleration, is defined as the velocity squared over the radius. In this case, we know both of those values, so we can go ahead and plug them in immediately to get our answer. So we say 3.60 squared over 8.6, and plugging those numbers in, we get the value 1.51 meters per second squared, and that's rounded for sig figs. And then the final part of the problem asks about the speed of the child at this second location. So we're going to perform the same kind of procedure that we did here, but instead of, or ask about the acceleration at the second location. So we can use many of the same formulas. Let's start with the acceleration one. So the acceleration, in this case, case 2, that was case 1. In case 2, the centripetal acceleration is still defined as velocity squared over radius, but this time it's going to be velocity 2 squared over radius 2. That was velocity 1. This was radius 1. And now we're talking about our second case scenario. So in this case, we don't know the velocity at the second location. We knew it for the first one, but we don't know it for the second one yet. So I'm going to go ahead and use other formulas to substitute in until we can get to a point where all of the variables are a quantity we already know. In this case, the way I chose to do it was by redefining velocity. So I can say that the velocity is equal to 2 pi r2 over t, and then squared over r2. At this point, I can simplify this expression to say 4 pi squared r2 squared over t squared r2. And then I can further simplify this by eliminating one of those r2's from the numerator and the denominator. And at this point, we do know all of the values involved in this expression. So we can go ahead and plug them in, which is what I'll do now. 4 pi squared times the new radius is 6.7 over the time, which is still 15 seconds because it takes the same amount of time to rotate at any point on the circle, squared. And then when we evaluate those numbers and round for sig figs, we get 1.18 meters per second squared as our final answer. So those are the 3 answers for this problem.